How do you actually know whether an implementation follows the rules of the intended architecture and design? In my experience, you will mostly have to analyze dependencies of some sort. But how do you visualize the results of your analysis? Keep watching, because this is exactly what I'm going to show you in this video. In part 2 of this series, we have seen how easy it is to generate, for example, a dot document from an output of other analysis tools and load those into Plainion.GraphViz. Of course, we can continue writing own scripts and tools to generate dot files, but it is certainly more convenient and also provides higher flexibility to add analysis tools to Plainion.GraphViz. And how you can do this I will show you now. Suppose we already have a script which is reading references, project references and package references from .NET projects. As a result, it generates a data structure which could then be used to generate any kind of output. In the next steps we will see how we can integrate this analyzer into Plainion.GraphViz. In principle, Plainion.GraphViz is extensible, but we don't have an SDK NuGet package so far. So in order to develop an extension, you have to fork the project, and of course you can send me a pull request if you want to share it with the community. Let me know in the comments below the video whether an SDK NuGet package would be preferred. Once forked, we see that the solution contains an SDK project which can be used as a copy and paste template. So let's create a copy and rename it, including the namespaces. Every extension has to start with Plainion.GraphViz.modules in order to be loaded. The rest of the name can be chosen freely. And here we go. Let's get an overview on this new project. Plainion.GraphViz uses Unity as dependency injection container and the Prism library to build modular applications. The UI uses WPF and we try to do as idiomatic MVVM pattern as possible. The entry point for every Plainion.GraphViz extension is a Prism module. The name of every Prism module needs to be unique across the whole application. So let's rename that one as well. The entry point from UI perspective is a menu entry in the Tools menu, which we register here. Let's open the Tool menu item, and we can change the label of the menu here, and we will change it to VS Project Dependencies. The menu item uses so-called interaction requests to open a dialog once clicked. When the request is triggered, a pop-up window action is called, which then uses the region manager, and here the region is defined, to decide which content should be placed on that dialog. Of course, the Tools menu item also has a view model, which is injected into the constructor using dependency injection, and here's the view model. The view model also defines the title of the dialog. Let's change that one as well. The view which should be placed in that region is also configured in the module here. Let's look at that view. It already defines some content, basically a button and a text box, which allows you to specify the folder of the codebase you want to analyze, as well as two buttons to cancel the whole analysis or to start the whole analysis. Of course, this view also has a view model, which is also injected using dependency injection into the constructor of the view, like here. And this view model now defines some basic dependencies which every analysis would need, like the presentation creation service and the status message service. It also defines the commands which should be fired for the buttons I explained. And it also wires up this basic interaction like selecting a folder, starting the analysis, canceling the analysis. And it also already contains some sample code, how to create a graph and a graph presentation out of the result from the analysis. In this sample code we also already have an analyzer, which is not yet doing anything, but returning an analysis document, which will contain the actual result of the analysis. And the analyzer is triggered by the view model when the Create Graph button is clicked here. Let's build the whole solution and then start the viewer application to see whether that basic sample code already works. And here's our new menu item, and if we click on it, we also get this dialog already. In the next step, we just copy our existing analyzer and related classes into the Plainion.GraphViz extension we are creating. Let's build the project to see whether we copied everything correctly. Looks good. Now we have to consume the analyze document in the configuration view model, and we have to build a graph and a graph presentation from the data provided. Let's start by uncommenting this part. So in case some items, some Visual Studio projects could not be analyzed correctly, we can use the status message service to report this information to the user. Let's remove the to-do, and we already handle errors properly. Now we want to create a graph from the projects we have analyzed. So as the to-do suggests, we use the graph builder to build that graph. Obviously a graph consists of nodes and edges, but the graph builder allows us to only add the edges. The nodes will be added automatically. So let's do this. We will use the full path of each project as the ID for a node, and therefore we will use the caption module to define just the name of the project as the visible displayed name of the node. And we will use the tooltip module to show the full path of the project as a tooltip when the mouse is hovering over every node. Now we will have to add the edges for every project. Every project can have 3 different types of references: assembly references, project references, and package references. So we will add those one after another. A project reference will be represented by a path, so we can use this directly as the target node. Every edge we build from source node to target node. And we will get an edge returned by the builder, which we can then use together with the edge style module to define a specific style for that edge. Now let's add the assembly references. As the name states, these references contain assembly names, but as we want to use the full path to a project as the ID of a node, we first have to create a mapping between assembly names and project full paths. Now we can process those references. Of course, we can only get the full path of those projects we know, means which belong to the codebase we have analyzed. And also in this case, we want to give this edge a different style. And finally, let's add the package references. A package reference is obviously not part of the codebase we have analyzed, so we can only take the package ID or the package name as node ID. And let's add some other style here as well. Okay, that's it. Let's build the project. Okay, succeeded. Let's run the viewer. And if we now run an analysis, we should see a graph as a result. Let's take the Plainion.GraphViz codebase itself as an analysis example. Select this folder and run. And here's our graph. We see the different nodes. If we hover over one, we also see the full path in the tooltip, and we see the different colors we have selected for the edges. That was pretty easy, right? We could now add some more flexibility to our analysis by, for example, adding a checkbox to the dialog, which can be used by the user to decide whether third-party references should be included in the graph or not. So let's go into the configuration view, and we simply add a checkbox above the buttons, like this. Of course, we need a property in the view model to bind the value from the checkbox to. Let's simply add this here. Now we have to respect the value of this property when building the graph. So project references obviously always belong to the codebase, they are never third party. Assembly references can be third party, and we detect those by checking whether we found a project for those or not. And package references are actually always third party. Okay, let's build the project again and run the viewer. Let's run the analysis again. Here's our checkbox. We select the same folder. Let's keep the checkbox unchecked for the first run. Now we see again the graph with all the references, even the third-party ones. And if we now check this checkbox and just run the analysis again, we immediately see the effect that all third-party references are ignored. That's it for this video, and actually for the entire series. Using the ideas and tools shared in this series, you can now discover the real design of a codebase and compare it with the intended one. Share your experience of using graph analysis and extending Plainion.GraphViz with the community by leaving a comment below the video. And if you now want to ensure to design your next system with proper dependencies right from the beginning, then watch this video next.